Okay, for lesson 25, we have measures of central tendency. Central tendency is mean, median, and mode. And dispersion. Dispersion is going to be looking at our range and our standard deviation. So, let's go ahead and get started. We're talking about statistics. Okay, that's a branch of mathematics that involves collection and analysis and comparison of sets of numerical data. I've already talked to you guys about how central tendency, we're looking at the middle set of data. When we're looking at the middle, we're going to be looking at the mean or the average. One thing that's new for you guys is this X bar, and it's literally said X bar. Okay, that's just a notation for mean. Then we have our median, which is the middle number. Make sure you write them in order. And then the last one is mode, which means most. I think Mrs. Lucas had a song that you guys remember for this, so Hannah and Will are going to take it away.
Mean means average, mean means average, mode means most, mode means most, median in the middle, median in the middle, now you know, now you know.
Thank you, Will and Hannah. It was very nicely done. So, let's practice real quick, finding the mean, median, and mode. Our mean, I don't know what happened there. Sorry about that. Our mean, you are going to add up all of the numbers in this list. 16, 13, 12, 15, 18, 14, 14, and 17. And then we count. There are 1, 2, 3, 4, 5, 6, 7, 8. 8 numbers, so we need to divide by 8. If I add all that up, on top I have a 119 over 8, which is approximately 14.9. This sign right here, the squiggly equal sign, means approximately. If you guys round that to 1 decimal place, you should be good. Then we have our median. Remember, for the median, you need to put all of your numbers in a row. Put all of those numbers in a row. You need to find the middle number. So when I do this, I always like to kind of cross out on each side. Taking them away, taking them away. Oh, crap. Our median has 2 numbers. So what's the middle? Well, if that happens, we need to find the average of those 2 numbers. So I'm just going to take 14 plus 15 and then divide it by 2. My median is 14.5. The last one is mode, which you guys should remember with mode. That's just the number that occurs the most. If I look up here, you have a 14 twice. All the others only occur once. So 14 is your mode. Okay? Nothing too difficult there. Next, we have our measures of dispersion. This is a statistic that indicates how spread out or dispersed the data values are. So, common measures are going to be range, variance, and standard deviation. Range, all you do is you take the largest minus the smallest. Variance, we're not going to look at this one, okay? But variance is basically standard deviation. I'll talk to you guys about that in a second. Our last one is standard deviation, and this is important. Your standard deviation measures on average how far away from the average are your data values. So what we're going to do is we're going to find the average of the data, and then we're going to figure out how far away each of those numbers are from that average. And we're going to average that. So that sounds kind of confusing, but the good news is that the formula for it is even more confusing. Okay? I've got each of my individual numbers, and I am subtracting them from my mean so that I can figure out how far away they are. Then I add each of those distances up after I square it. And the reason that I square it is because some of those numbers are going to be negative. And if you're adding negatives and positives together, that's not going to give you the true average distance from each other that they are. I divide by n, which n is just the total numbers that I have. So remember, I'm finding average. If I look at 3 distances, I would need to find it or divide it by 3 to figure out the average distance of all those. Okay? And then you have this big old honking square root. Why do you have that big square root? Well, you've been squaring each of these numbers here, so you need to get rid of that squared by doing your square root. Okay? Now, I told you guys that there's a relationship between standard deviation and variance. Your standard or your variance is just your standard deviation squared. So we're not going to really talk about the variance. We're just going to focus on our standard deviation. Something else that I realized I should have told you guys earlier, this little symbol here, that's sigma. It's a Greek letter. Okay, I just draw a circle and put a line off the top of it. That's how I draw my sigma. Stigma is what they use to notate for standard deviation. I think I might have just said stigma and I meant sigma. Sigma is what they use for standard deviation. Okay, so we've got 5 numbers here and it wants us to find the range and the standard deviation for our following set. So I've got 3, 4, 5, 7, and 9. Range is going to be very easy. Biggest number minus my smallest number. 9 minus 3 gives me 6. And 6 is my range. That's all I have to do to find the range. Now next, I need to find my standard deviation. But before I can find my standard deviation, remember your standard deviation is on average. How far from the average are each of these numbers? So I need to find my average of these numbers first. So to do that, I need to take 3, 4, 5, 7, and 9 and divide it by 5. When I do that, I get 28 over 5, which gives me 5.6. So my mean for these 5 numbers there is 5.6. Now that I know that my mean is 5.6, I'm ready to figure out my standard deviation. So standard deviation is on average, how far from the average are each of these numbers. So my first step is to figure out how far from the average they are. So I'm going to take 3 minus my average, which is 5.6. I'm going to take 4 minus my average, which is 5.6. I'm going to take 5 minus my average, which is 5.6. I'm going to take 7 minus my average, which is 5.6. Oops, forgot to write the 5.6 in red. And I'm finally going to take 9 minus my average, which is 5.6. Now remember, we're trying to find on average how far away each of those are, right? So there's a distance, there's a distance, there's a distance, there's a distance, and there's a distance. If I'm finding on average, I want to make sure that I'm adding all of these distances up. And since there are 5 distances, I need to divide by 5. Okay? Again, we're missing some parts here. I need to make sure I put a squared. And the reason I need to put a squared is that these 2 numbers here would result in negatives. And that's going to screw up trying to find my average distance. So all of these numbers have to be squared to make sure that they are all going to be positive and we can add them up. Okay? Then, because I squared them, that's probably going to skew my number. So I'm going to take a square root of the whole thing to try and fix that. So, once you guys get all that plugged in, all it is it's plugging and chugging. So I'm going to start out 3 minus 5.6. 3 minus 5.6 gives me a negative 2.6. Then after my negative 2.6, I need to square it. So when I square that, that gives me 6.76. So I'm going to write 6.76. Then I'm going to move to my next one. Plus 4 minus 5.6. That gives me a negative 1.6. Then I need to square negative 1.6. That gives me 2.56. Okay. Next one, 5 minus 5.6. And 5 minus 5.6 gives me a negative 0.6. Then I need to square that. That's going to give me 0.36. Then I've got 7 minus 5.6, which gives me 1.4. Square that. That's going to give me 1.96. Then I've got 9 minus 5.6. That gives me a 3.4. Square that. That's going to give me 11.56. Okay, so those are my 5 distances. So I've got to divide those by 5, take the square root of the whole thing. So I'm going to do 11.56 plus 1.96 plus 0.36 plus 2.56 plus 6.76, and that equals 23.2 divided by 5, and I've got the square root of that. So if I take 23.2 divided by 5, that's going to give me 4.64, and I need to take the square root of 4.64, which gives me approximately, it's not exact, approximately 2.15. So my standard deviation is 2.15. Essentially what this is saying is that on average, each of these numbers are about 2.15 from the average. Okay, it's not exact. The squares and the square roots don't work out exact, but that's basically what that is saying. Okay, I'm going to finish the second part up of this video on another video.